Hello everyone, welcome to Robopreneur. Today in this video I'm going to tell you about the fundamental of robotics. So let's start the session. The first thing is whenever let's say we are saying robot, so what things comes in your mind? So first I will just go through the slides and I'll be explaining about the robotics parts, and then we will be learning different kinds of robots. So let's start. So what is a robot? Robots are machines that do some kind of action, right? And robot is actually made by this word robota, which means forced labor. Now let's see the parts, the classification of the robots. So there are three kind of robots: manual, autonomous and semi-autonomous. This is the based on control method. There is another method, so we will be looking at later on this thing. So what is a manual robot? In our childhood, we all have played with remote control cars, isn't it? So manual is just a remote control car where you will be giving the instruction with the help of remote, and your model is going to work according to that. Now, autonomous. What is autonomous robot? Autonomous robot is nothing, it's a robot. By the name, actually you can guess it. A robot which walks by own, that is called autonomous, isn't it? So autonomous means, of course, there has to be some sensors, there has to be some microcontroller. Like as a human being, we have a brain and we have a sense organs to sense. So with the sense organs, we can sense the surrounding and we can feel. As well as same thing, if same ability you have to give to the robots, so that it can sense the surrounding and accordingly it can take the decision. So that is called autonomous. Let's say I want to make a line follower robot. As you can see here in this image, this is a line follower robot. So this robot is programmed such a way so that it will only follow the black tracks. So again, there are three sensors are here. So a programming is done to the microcontroller, which is the brain of the robot. And only initially you need to do the programming. After that, once you finish the programming part, it is going to execute its task automatically. That's why it is called autonomous robot. Now the third thing is semi-autonomous robot. What is semi-autonomous? So by the name, it is clear, a robot which walks by own, but at some point of time, you have to control it manually. In the image, you can see the example. This is the arm. So the robot will go near the object by own. So whenever it will detect the objects, the arm you have to control manually so that you can pick the objects and then it can move to its destination. Okay, so there is one more real-time example which we are actually using in our home of semi-autonomous. Can you guess what is that? One of the semi-autonomous application actually we are using in our home. Guys, if you are new on this channel, please subscribe to Robopreneur channel. So I was just telling about semi-autonomous. One of the semi-autonomous application is actually present in our home, which is nothing just a washing machine. Why it is semi-autonomous? Because what I told, in semi-autonomous, two things are required. First thing is you have to control manually, and at some point of time it will actually work by own also. But at some point of time you have to control manually. Same thing is happening in washing machine. Initially you need to set the timer, so that for that you will be doing manual work, and once you set the timer, it is going to execute its task automatically, and once the time will over, the buzzer will automatically get buzzed. So these are all are the three different category of the robots: manual, autonomous, semi-autonomous, which is based on the control method. Now let's see the next slide. So classification of the robots based on locomotion. So probably you have seen this wheeled robots, and then this is the walking robots, this is flying robots, which is made by Festo company, then swimming robots, slithering robots, arm robots, and wall climbing robots. So these are the category based on the locomotion where we can classify the robots. Now next, so let's discuss about the parts of the robots. So first thing is, of course, as a human being, in order to walk, we need food. But in order to walk the robot, what does it needs? It needs, of course, power supply. If you give the power supply, it is going to walk. Otherwise, it cannot, right? So, of course, power supply is required, which is the essential things for a robot. Then, a robot should have some mechanical structure. It should have some body, chassis, wheels, motors, gears, and there are different kind of motors based on the application, for what application you are going to build a robot and where you are going to deploy that. Depending on that, you can choose an appropriate one. So second part is mechanical accessories, and third thing is electronics. Under electronics, there are a lot of things will come, like sensors, which is motor driver, Bluetooth controller, and many more. So let's move to the next slide. Yes, so there are two kind of power supply. In our home, alternating current comes, right? But can we store alternating current in a battery? Can we store this? No, we cannot. Only direct current we can store. So robot uses direct current. Robot uses a battery which is DC. So you can see in our home, alternative current comes, and this is the graph of AC, and this is the graph of DC, which is a straight line, if you see. Yeah. So power supply, there are two kind of power supply, AC and DC. I hope this is clear. So let's discuss about this. This is the graph of AC. So in our home, the AC comes and its frequency is 50 Hertz, and number of cycle per second is called frequency. So basically this is a frequency cycle. And what is frequency? Frequency is a cycle per second, and the unit of frequency is Hertz. Let's move to the next slide. Now with an analogy, we will understand the basic of electronics, which is voltage, current, and resistance. So in this video, guys, I'm going to cover the electronics part. So if you want to build a full-fledged robot, so three things are required. First thing is, you need to know how to make the circuit diagram, how to build circuits, and then the second thing is, you will learn how to build the body of the robot, how to create a structure, how to create a four-wheel robot. Then if you want to make a pick and place robot, basically a robotic arm if you want to make, then you need to know what kind of gears you need, and what is the mechanism to fix the gears in a proper place. So in this video we are going to learn about the electronic circuits, and probably in the future video we will do the mechanical things also. And the third thing is programming. So for building a full-fledged robot, basically three things are required. First thing is electronics. You should know how to make the connections, how to build circuit using sensors, using electronics components, which is transistor, LEDs, resistor, and then gate IC, 555 IC. There are a lot of things in electronics. So first thing we will learn about the electronics. Then of course mechanical thing is required to build a structure of a robot, so which we'll be learning. And then third thing is, we have to learn how to make autonomous robot. So if I say autonomous, it means programming is required. And of course there has to be some microcontroller, so which we'll be learning in the future video. In this video we are going to focus on the electronic circuit, and today we will be doing one activity and we will learn about electronics fundamentals. So with this picture I am going to explain you voltage, current and resistance. So here you can see, first I will explain the voltage. So water is actually contains in tank A and it is actually going to tank B. Why so? Because tank A is actually applying a pressure. Whatever water is actually contained in the tank A, and due to the pressure, down pressure is happening, and due to that water is actually moving from tank A to tank B. So this pressure is actually called voltage. So voltage is actually a kind of pressure which takes the current flow from one end to another end. Again, you can see this is a very thin pipe. So if we will make a very big pipe, like width if we will increase, then more water can flow through this. So this thin and wider things are called resistance. If we make more thinner this thing hole, then very less amount of water can come out of this. But if we keep on increasing the width of this thing, this hole, then the water amount will keep on increasing. So this is called resistance. So resistance, we can say it's a kind of it's opposing the flow of water, because here we are assuming water. So but in the electronics you can assume the flow of water is called current. Why so? Because in the wire what flows? Current. Here what is flowing? Water. So we can analyze like however the water is flowing in the tank, in the tap, same way current flows in the wire. And what is the voltage? Voltage is a kind of force which is actually pushing the currents so that it can flow in an electric circuit. And what is the resistance? Resistance is which opposes the current so that it cannot flow. But can a resistor fully block a current? That is one question. Can a resistor fully block the current? Yes, it can. If you increase a very high value resistor, then of course it can stop the current to flow, but still a little bit of current will flow. It cannot block fully current, but of course a little bit can flow in the circuit, but that little bit current will not enough to run the components. So let's move to the next slide. So same thing here, you can see this is the Ohm law. I equal to V by R. V means voltage, R resistance, and I is a current. So the unit of current is ampere and the unit of volt is volts, and then the unit of resistance is ohm. The unit of voltage is volt. So you can see voltage is actually potential difference between 2 points. That's why if you observe, every time you have seen the tank, water tank is actually present on the top of the roof, so that there has to be some difference from the tap to the tank, so that more pressure can apply more pressure, so that more water can easily come from the tap. This is resistance. So here you can see this is wider, more water is coming from this second one, and the right one is actually thinner pipe, so very less water is coming out of this. Okay, moving on. Okay, resistor limits the flow of current. Generally resistor is a coil of wire. More the number of coils, more is the resistance. The unit of resistance is ohm. Now what is an electric circuit? So an electric circuit is a closed conducting path through which current flows. So here you can see the current is coming, and here open circuit is there. That's why the bulb is not flowing, and this is the closed circuit, and that's why the bulb is glowing. You can see again here Whenever switch is pressed, the circuit is getting closed. Whenever switch is not pressed, it is open circuit. Open circuit and then closed circuit. In closed circuit, the bulb is glowing because the conducting path has to be closed. If the conducting path is not closed, then it is called open circuit. If the conducting path is closed, then it is called closed circuit. And this is the symbol of resistance which we will be seeing in the circuit diagram. And this is the symbol of battery. Now there is one more condition, open circuit and closed circuit. Apart from that, there is one more condition which is called short circuit. What is a short circuit? So if you connect positive and negative of the battery to each other, then it is called short circuit. In this situation, huge amount of current is going to flow. Due to that, sometimes battery can burst. So we have to be very careful while doing the connection with the battery, because if by mistake we do the wrong connection, it is going to do short circuit and your component can also be damaged. Moving on. Yes, so in this video we are going to learn about the series connection and parallel connection. So we'll be connecting multiple LEDs to do this. So before that, let's understand what is an LED. So a LED is a light emitting diode. It's a semiconductor device that emits lights when an electric current flows through it. When current passes through an LED, the electrons recombine with holes emitting light in the process. LEDs allow the current to flow in the forward direction and it blocks the current in the reverse direction. This is the symbol of LED, and this is a very simple circuit of LED. So let's do the simulation, let's do the practical. So basically I'll be using one simulation software which is an open source software, Tinkercad. So let's connect a circuit of LED. So first I will take a simple LED, one LED, then I will take a multiple LED, then for explaining series and parallel connection. First let's take one LED and let's take a resistor and let's take a battery. Instead of battery, let's take power supply board, power supply, this, yes. Using power supply, we can vary the voltage. Let's see how much voltage is required by the LED to glow. So I have used one resistor, which is 1 kilo ohm. And then this is coming from positive end of the LED, and then negative end of the LED, let's connect to the negative of the power supply. Yes, so this is what we have seen in this circuit. This is the circuit, this is the voltage source, this is the resistor, and this is the LED. Same thing I have done here. Let's do the simulation and let's see how much voltage I am applying here. I am applying 5 volt and the LED is glowing. Let's decrease the voltage. Let's use without resistor. Let's see how much voltage is required to glow an LED. So this time I will not connect a resistor so that we can measure the forward voltage of an LED, because in the reverse direction LED will not work. So I have connected positive to positive and negative to negative. In this situation only LED will glow, and this state is called forward state. In the forward state the LED will glow. So let's see how much voltage is required, how much forward voltage is required. So here you can see the LED is burst, LED is fused. You can see LED is fused because we are applying 5 volt and there is no resistor. It means LED doesn't need 5 volts, so let's decrease this voltage. Okay, so let's click here and let's write 2 volt. And here you can see LED is glowing. Let's decrease more. Let's write 1.5. And what you can see, LED is glowing, but it's very dim. So clearly we can say LED is required. The LED forward voltage is 2 volt. Okay, so now we came to know LED is required 2 volt, and if you are applying more than that, of course you have to use resistor to limit the current. That's what we have read in the slides. Resistor is used to limit the current. Okay, now moving on. So now we will learn about the series and parallel connection of LEDs. So what happens in series connection? So the same current flows through each LED. The first thing you can see, the same current flow through each LED. The total voltage of the circuit is the sum of the voltage across each LED. So here I am reading the things, but apart from this we will be doing the practical things, so that line by line we will get to know all the things. First line is the same current flows through each LED. Let's see this. So let's connect 3 LED and let's see same current is flowing or not. So I will take 3 LED, and how to do the connection, how to do series connection, that's what also I'll explain here. So in series connection, the positive of the first LED has to be connected with the negative of the second LED, and the second LED positive we have to connect to the negative of third LED. So plus minus and so on. Here I'm using only 3 LED. Let's change LED color also. Orange. Let's change this color green, and let's change this color blue. Yes. Now let's connect. This is negative leg, so negative I have to connect to negative, and this is the positive end. Let's connect to positive end, and let's apply the same voltage, and we will observe. See what you can see here, with 2 volt it is not glowing. None of the LED is glowing, but we are going to measure this first one. The same current flows through each LED. That's what we have to see. The same current should flow through each LED. For that we need a multimeter. So with multimeter we'll be measuring, but 2 volt is not enough to glow this LED. So we will actually increase the voltage. So let's apply 9 volt. 9 volt is more, so let's apply 6 volt only. With 6 volt all are glowing at max brightness, and this is the current. So we have to measure the current. Let's stop this. For that, this is the positive and this is the negative. Let's start. We have to measure the current. (158 milliampere). Let's connect here, and this one let's connect here. Let's measure 158 milliampere. So first one, the right one and the middle one, both are same current, both are getting same 158, and now it's time to check the third one. Third one, yes. Now let's start again. 158. So all are getting same amount of current, right? So in series connection, this is true. The same current flows through the LED, through each LED actually. Then the total voltage of the circuit is the sum of the voltage across each LED. The total voltage of the circuit is the sum of the voltage across each LED, which happens in series connection. So let's see that. First, let's remove the multimeter. This one, yes, and this wire also, yeah. So we are applying 6 volt. I'm applying 6 volt, and all LEDs are glowing. But now we have to check across each LED the voltage should be same. We are giving 6 volt. So 6 divided by 3 LED. Every LED should have 2 volt, because this voltage has to be divided across each LED with the same amount. So let's click on voltage. First let's connect. So I'm going to measure the voltage across this one, across the right one. Let's start. Yes, 2 volt. So what you can see here, 2 volt. Let's see the second one also. Minus. Let's remove this one here. Yes, let's see again. This is also 2 volt. Of course, the left one will be 2 volt only. So this is also true. The total voltage of the circuit is the sum of the voltage across each LED. We have verified this also. We were applying 6 volt and every LED was getting 2 volt. 2 plus 2 plus 2. It's 6. Okay. Now, if one LED fails, the entire circuit would not work. If one LED fails, the entire circuit would not work. Let's see. Suppose from here the wire is broken. So will it work? This is open circuit. It will not work because this is open circuit. And one more condition can be happen. If one LED is fused, then others are actually not going to work. That is also there. So in that situation, you have to replace that of one LED, then others will work. Otherwise, it will not work. So that is the problem in series connection. If any one of the LED is fused or damaged, then none of the LED will work. Series circuits are easier to wire and troubleshoot. So you can see the connection is very simple. You can just keep on adding the number of LED. Just positive to negative and then positive to negative, and this is how you can connect a multiple number of LED, and the connections are quite simple. Moving on, now let's do the parallel. Okay, in parallel connection, see the condition. The voltage across each LED is the same. In parallel connection, what happens? The voltage across each LED is same. And in our home, actually, all the wirings, electrical wirings are actually connected in parallel. And in our home, alternating currents comes, and all the electrical wiring is done in parallel, so that every electrical appliances take 230 volt, 240 volt. Because electrical appliances work on 230 volt, 240 volt. So in order to keep all the same voltage, we have to do the parallel connection. So in the parallel connection, what happens? Every appliances take 240 volts, so that it will work properly. So we will verify this also. The voltage across each LED is the same. But let's do the parallel connection now. This is the series connection. Now I'll tell how to do the parallel connection. So here in the circuit diagram, you can see all negative of the LED, the upper one is the negative. All negative of the LEDs are actually connected to each other, and then bottom one is positive. All positive are actually connected to each other. Okay, I will show here only. I will show here. Yes. So in parallel connection, all plus of the LED we have to actually connect to each other. So I'm going to connect all plus of the LED to each other. Okay. So let's change the wire color. This is red. This is also, let's make a red because this is positive. Otherwise we can be confused. Let's see this one because this is negative. So black. Yeah. This is also negative. So what I have done, I have connected all negative to negative, all positive of the leg I have connected to positive. And now let's apply the voltage. This is positive, so I will connect here. Let's change the color, positive, and this is negative. So let's connect here, change the color, negative. Yes. Now let's do start simulation. 6 volt I am applying and all the LEDs are actually fused, but we have seen in the series connection 6 volt was required to glow all together, but here 6 volt are actually high volt, so we have to decrease the volt. And let's see, all LEDs are actually required 2 volt to glow, right? We have checked, we have seen LED only needs 2 volt to glow, so let's write 2 volt. And what you can see here, with 2 volt all LEDs are glowing, but in series connection we have to apply 6 volt in order to glow all together. So that is the main difference. If you observe carefully, in the series connection we had applied 6 volt to glow 3 LEDs, because if you are applying less volt like 5 volt, 4.5 volt, so 3 LEDs were not glowing. But here in parallel connection you just need to apply 2 volt, because LED is actually need 2 volt to glow, and multiple LED you can connect in parallel connection, all will glow. So there is one more thing. The total current is the sum of the current through each LED. This is one another thing. The total current is the sum of currents through each LED. So let's measure this one. So again, let's take the multimeter and we'll measure the current. For that, first one resistor is required, because we cannot directly connect this thing across power supply bench. This is plus, and then this is minus. I will connect to minus. A minus. Yes. So this is minus, this is plus. Let's change the color so that you won't be confused. Yeah. Let's measure. So 2 milliampere. Total current is 2 milliampere. Because we have used the resistor, that's why it is showing 2 milliampere. Otherwise, here you can see it is showing 36 milliampere. Okay. Now, same thing, 2 milliampere, and now this is negative. I will connect to negative of this LED, and this is positive. I will connect here. And let's do the simulation. What you can see, it's 2 milliampere. And again, let's stop this. Let's connect here, and this is also, let's connect here. Second LED, 2 milliampere. So everyone is actually getting 2 milliampere. So the main difference is, in parallel connection we just need to apply 2 volt to glow all LEDs. I will show one more LED. Let's connect one more so that it will be more clear. This is positive, we have to connect to positive, and then this is negative. negative we have to connect to negative, negative change the color black, and then positive we have to connect to power supply positive, red. Now again we are applying 2 volt only, and what you can see, all are flowing. But in series connection it's completely different. If you are using 4 LED, how much voltage you need? You need 8 volt. Then only all LEDs are going to work. Let's see series connection with 4 LED, and let's see the voltage. So let's see this wire. Now this time I'm going to connect 4 LED, and as per the calculation we need to apply 8 volt, then only all are going to glow. If we will apply less, then it will glow, but probably it will be dimmer. Plus of the left one, minus, then plus, then minus, then plus, then minus. It's very simple connection. And then minus, I'm going to connect to minus, and then plus, I'm going to connect to plus. That's it. Minus, let's change the color of this one, black. Okay, let's do the simulation. 2 volt is not enough to glow all the LED. Let's increase, let's put 6 volt. What you can see, it's glowing, but it's very dim. It's very dim. So what we have discussed every LED needs 2 volt. Each LED needs 2 volt. So 2 into 4, 8. And what you can see here, I'm applying 8 volt and all are glowing. So hence it is proof in series connection you have to apply that much volt, so that every LED can get 2 volt. Then only it is going to glow, otherwise it won't. So I hope guys you enjoyed in this video. If you are new on this channel, please subscribe and like the Robot channel. So in the future we will be doing others live video we'll be releasing, and you will learn a lot of things. So